Good day everyone, welcome to our channel BST African Electronics Surgery. We do have this Lenovo laptop and let me see the model. Lenovo G570. The laptop came in as no power. Yeah, no power. So let's try to fix this. This is some kind of old Lenovo laptop, but we have to fix it. Let's see what the laptop is doing exactly. With the help of the power supply, I'll connect this cable straight away to the power supply. You can see the power supply is set on 19.12 volts, around 3.5 amps. So connecting the power supply is taking 15 milliamps, which is the right standby current. Pressing the power. I'm pressing the power button here. You can hear the button is clicking and is stuck at 15 milliamps standby current. Okay, so what can be the fault? What can be the fault? "15 milliamps standby current", it means the main 19 volts power rail is not shorted. That's what the power supply is communicating with me. If I've seen something like that, I will know that the main 19 volts power rail is not shorted. So if it's not shorted, either we have the problem with the 3.3 volts power supply, which is always on all the time. The chances of that power supply to fail is very high. Or can be something, can be anything. Can be anything. Here we have some power supplies, we have ceramic capacitors. I think we can check few things before we get inside the laptop. The design looks fine. So connecting the power supply, you can see that 15 milliamps standby current. Let's check the main 19 volts power rail. Here on these coils, what do we have? We have 4.4 volts. 0 on the plus, 4.48 volts. So the main 19 volts power rail has got 4.48 volts. 4.48 volts means something is not right with the input Mosfet. Maybe we have a blown up motherboard and the Mosfet is just outputting a little bit of voltage in most cases, or something is not right with the DC input Mosfets. So how do I get inside this one? How do I get inside this one? Too many screws. You know, I hate this design. Let me get inside the laptop and we'll see how to fix this. So that's the motherboard for our Lenovo G570. And what did I found? What did I tell you when we are having like 4.48 volts on the main 19 volts power rail. This MOSFET is blown up. You can see here. Maybe you can see we have one blown up MOSFET. We have the second blown up MOSFET. On the other side, we have another MOSFET. Another blown up MOSFET here. We have like 3 MOSFETs. The first MOSFET is blown up. The second MOSFET is blown up. And that MOSFET, which is there to supply power from the battery. When the laptop is working with the battery, the power is coming from the battery to the motherboard. And this MOSFET is blown up. So you have a challenge here. We have a challenge. Let's see under microscope. Let's see under microscope. Check here. Check here. This is the MOSFET, and the piece of the MOSFET is this one. That's the MOSFET which is blown up. Probably this is the first or second MOSFET. We have another one. When the laptop is working with the battery, this MOSFET is also blown up. And where's our third blown up MOSFET? Our third blown up MOSFET is here. Okay. So what I will do, let's see if this MOSFET has anything to do with the current sensor, current resistor. Let's see if this MOSFET has anything to do with that green resistor with the current sensor. To ground. This MOSFET is not. The current sensor is, the main 19 volts power rail is not shorted to ground. You can see. And this MOSFET is not going. So that's our first MOSFET. So this MOSFET has nothing to do with the current sensor. That gives us a conclusion. That is the first MOSFET. And our second MOSFET is the one which is the one which is completely fried up. This one. Let's see if you can bring this to life. Let's see if you can bring this to life. The board layers looks fine, but the thing is, we can't put another MOSFET here anymore. We can't. That's the thing. We can't put another MOSFET here anymore. Let's clean here. Maybe. Let's took down the second MOSFET, the first MOSFET, because this MOSFET is also blown up. Let's took down this MOSFET. Our MOSFET is out. Yeah, let's first fix those input MOSFETs first. So what I would do, what we can do here, how should we fix this? How should we fix this? An idea? An idea on how we are going to fix something like that? The solution is very simple. The solution is very simple. I will show you. I'll show you how we can fix something like that. The solution is very simple. We'll run our wire from this point from this inductor, that's the inductor coil, in serial mode with the plus of the charging port. Just like that. And I'll need to run a wire just to bypass those input MOSFETs. I know it's dodgy, but there's nothing I can do here. So I need to run a wire from, okay. Just like that. So now we need to fix that MOSFET for charging. Now we need to fix that MOSFET for charging. So yeah, even this MOSFET is blown up. So let's see. Let's see. Let's see. Do you have a shorted power rail? Let's come with the power supply. I'll lower the voltage to 4.93 volts on the main 19 volts power rail. I want to see if that bridge is not shorted to ground. Our wire, no, it's taking like 7 milliamps, which is a good standby current. Now, where can I get this MOSFET for charging the battery? Where can I get this MOSFET? From the plus of the battery connector, it's coming through a fuse, and the fuse is good. After the fuse, we have this inductor coil. And it's coming to the drain of that MOSFET. Where can I get this MOSFET? Where can I get this MOSFET? Where can I get this MOSFET? Yeah, I'm checking from a different board. I think we can get the MOSFET here. How this board is working? Was we must replace with a proper MOSFET here. The plus, the output, from the output. Okay. Okay. Where are my MOSFET? Where is my MOSFET to charge the battery? Not to charge the battery, but to supply power to the motherboard from the battery. This one is confusing me. Let me look for another motherboard. What we want drain to source, not source to drain. We want 4 pins connected on the plus of the battery. Now that's the hard part, to find the proper MOSFET. And I found the MOSFET. I found the MOSFET. I found the MOSFET. So what we have to do is to replace that MOSFET which is supplying power to the motherboard from the battery. Let's replace the MOSFET. That's our MOSFET which is blown up. Coming with, let's took down this MOSFET. Doing the same job. I don't even know the motherboard. But what the MOSFET is doing exactly the same job. Exactly the same. Our MOSFET is in place. Let's see what we have done here. Let's see what we have done. Let's see what we have done here. That's the MOSFET. All the pins, they are properly soldered. So how did this happen? Like 3 MOSFETs all blown up. How did this happen? I don't understand how this happened. I'm confused how this motherboard died. So what I want to do, I think we can check. We can check to see how the motherboard is reacting with the power supply. I think we can check. Minus. We need to check some voltages on this board. So let's see if we have 19 volts, if we have 3.3. That's the most important thing. Do we have 19? Do we have 3.3? 19.15. It's taking 17 milliamps. Checking the main 19 volts power rail. $19.26, 3.3, 1.8, 3.27. You can see on the E.N.E chip. So we do have 3.3. We do have 3.3. We do have 19. So I think we are ready to test. I think we are ready to test. So all what I need to do, let's insulate this wire in this blown up area where there was the first MOSFET. I'm insulating with the hot glue. Just to make sure that bad things won't happen again. But I don't understand why 3 MOSFETs blown up. So let me put all together and we'll come back for the final test to see if we have a working laptop or not. Let's see now. I put the motherboard, and now it's that moment to test to see if everything is working. That is the moment. It's taking like 17 milliamps like before. That is standby current. Pressing the power on. It's taking 766 milliamps. And nothing on the screen. You can see the power on here. It's on, but we have nothing on the screen. Why? The motherboard is on, but we have nothing on the screen. Let's refit the RAM and the screen connector and try one more time. On. And the screen is displaying white. Oh, that's bad. That's a bad scenario. So you can see it's taking like 1 amp. The fan is spinning. That means the motherboard is fixed. And we have a secondary issue. Probably we have a faulty screen. This one doesn't have the HDMI. It's only working with the VGA. But I think I've done my part fixing the motherboard. And if we have a white screen, it means the board passed the test. So either we have a faulty screen, faulty ribbon cable, or something is not right. In most cases, it's the screen. In most cases, it is the screen. It is the screen. So we have I have to call the customer and explain him exactly what's going on. So we have to test to see why this screen is displaying white. We managed to fix the motherboard, which is good. But now we have problem with the displaying things. I don't think this is a good screen. I don't think so. But we will see. We'll see why the screen is displaying white. Why? Why do you have white display on the screen? Problem after problem. Let's see. Check out the screen. Let's plug back the screen connector. Let's try to power on the laptop again. On. Same story, white screen. So let me try the different screen. One more time. On. Fan is spinning. And the screen is displaying white. You can see. So what I want to do, let's unplug here. Let's unplug the screen. Let me test with a different screen. This screen is small, but this is a 40-pin connector screen. We want to see what will happen if we use a different screen. Let's power on. On. Lenovo. And we have picture. So this screen is faulty. So how this laptop died? So you see, we have done our job here. I managed to fix the motherboard. And if I'm to plug the battery, let me see. Let me unplug here. Let's plug the battery to see if we have a charging laptop. Let's put the charger. It's taking 136. Really? Power on. And it's taking like 1 amp. Okay, I know. Now it's taking 2.2 amps. You can see on the screen. It's charging. Why we don't have light here? Because I don't think I connected that cable to the LED here. So let me connect that cable. I want to be satisfied. I want to see the charging light. But based on what the power supply is telling me, it means we have a on. Okay. On. Why? Do you have a faulty battery? Or I just killed it again? What's going on here? Yeah, we still have a working laptop. We still have a working laptop. But if I am to plug the battery, if I am to plug the battery, let's work with the original charger of the laptop. Yeah, the battery is still discharged. With the charger, the laptop is on. And it's indicating, you can see that red light indicating. That means the battery is too low. You see that battery charging sign, which is indicating that a sign of either the battery is not recognized or is too low. I'm plugging the charger. Yeah, the battery is still good, but it's still low. Still low. Probably it's at 1%, less than 5%. So what I'll do, I'll stop this video. I'll communicate with the customer for screen replacement, because obvious is something, it's a different story. Otherwise, the good part is you have learned how to fix a blown up motherboard, like 3 Mosfets which were shorted, the first Mosfet and second Mosfet, and that Mosfet which is there to supply power from the battery to the motherboard on the input circuit. So yeah, this laptop has got too many faults. So like, comment and share our videos to our beloved friends and relatives, and see you on the next one. Bye.